Hi, everyone. Hello. How are you doing? I hope you're doing good. We're going to do Fibonacci Lab in a few minutes. So please check out Canvas Lab activities. Hi, Rashad, Sarah. Hi, everyone. Okay. So, okay, question. Yeah, what's your question? So for your quiz, let me see. Well, the good thing about the quiz is that you have 3 attempts, so you can always go back and do them. For the fraction, I kept them as fractions. Let me see. For the round, I think the only one that we would round up would be for the search and the sort algorithm, the search algorithm. When you're looking at the chunks or the number of comparison that it has to do. So yeah, it has to be whole number. Okay. So choose the viable options. And as far as the variations in the combinatorics area, you know, the calculation the result should be, one of the options should be the correct answer, in that it would be just in the thousands or in the hundreds. Okay. The only one that you would need to round would be the one from the chunk and the binary. Yes, those you have to round. And think about your worst case scenario. We talked about that when we did those calculations. So it's going to be very close to your assignments that we've done and the review. Okay. So I recommend attempting the practice quiz game, so that way you have an idea of how the quiz question would be. So try that one first. And if you're not happy with your quiz score the first time, you can do multiple times. So I open it for 3 attempts. So the best score of the 3 will be recorded. So you can always go back and redo them. Okay, so it is now 6 o'clock. We are going to look at our labs, and today we are going to do Fibonacci. So prior to the spring break, we touched on series and sequence. And then we talked about induction this week for proof and recurrence. We did some exercises on that. So this lab is going to look at the sequence, Fibonacci sequence. So if you look at lab 9, let me screen share here. And if you have further questions about quiz, if you want to stick around at the end, I'm happy to address specific questions, okay? All right, so for the activity, we are going to write some program to represent Fibonacci sequence. And the proof information, I just include in an attachment for you to see if you're interested in proof for Fibonacci. So you can read that if you like. Okay. So in Fibonacci for Lab 9, it starts with talking about what Fibonacci sequence is. And you see this in seashells, in flowers, in galaxy, in design. And it's very cool where we would see this in nature. We would see it in science, we would see it in art. And for math and science, most of the time when you learn about sequence and series, they would touch on Fibonacci. And it's one of the most common sequence that you will find that would be used in math and science. So in Fibonacci, sometime you would have the sequence seeding at 0 and 1, but for most part, you would find that they would seed at 1 and 1. So it would still be the same. Now, if we look at seeding from 0 and 1, so those are the initial values to start, then you simply take the first term and the second term and you add them to get to the third term. And then to get to the fourth term, we would take the two previous values. So 1 and 1, 1 plus 1 is going to give us 2. 1 plus 2 is going to give us 3. 2 plus 3 is going to give us 5. 3 plus 5 is going to give us 8, and so on. So it can continue forever. So in this example, you see that it seeds at 0 and 1, right? And in the case where it seeds at 1 and 1, if you start with 1 and 1, you would have 1 plus 1 is 2, and the sequence would be the same, as we would take the two prior values, add them to get to the next. So in order to get the result from the subsequent value, we have to be able to determine the two prior values. So in this activity, we're going to see that there will be times that we would use recurrence. And so when we look at the function for Fibonacci, we would see that f of n is going to be equal to f of n minus 1, okay, the one prior to that, and then plus f of n minus 2, two terms before that. So if you plug in the value for n, you will be able to calculate out your Fibonacci sequence. And for computer science, we would see that Fibonacci is implemented in heap data structure, in algorithms, in graphs. We will touch on graphs later on, in data structure, right? And you would see that distributed and parallel systems would have some representation of Fibonacci. So it's important to get the basic and understand how to program it. And outside of that, we see that biological settings, branch trees, fruits, flowers, ferns, things that we see, even pine cones would have pattern that would represent Fibonacci. So it starts with small and then it expands out larger and larger, and the pattern would repeat. That's what you would see in pine cones. Okay. So for number 1, let's look at example 1. And this is a very short, simple program using a function, right? So what we see, let me pull up my REPL. Here's REPL. So this is the program that we see, and let me make sure that it matches with the value. Okay. We have a function called fib, and the type is integer. we are going to pass a variable called n. That's going to be the position, right, of our terms. Then within the function, we define it with the if statement. If n is equal and greater than 1, we want to return n because that's going to be the starting values, the starting positions. So as we would seed it at 1 and 1, we want to include the if the control condition, so that way our function would have the initial point. So if it's greater and equal to 1, we want to return n. And we also, so if this is met true, we are going to return the n value. Then for the return statement, we would call the function, and in recursive functions, you would have a function calling itself, okay? So we then would call itself. So we would call the function and we would use n-1 for the one term before the current term plus fib. Again, we're going to call the function again for n-2, which is 2 terms prior to the current term. So basically, we are looking at the position 1 position before and 2 position before our current position. So in order to calculate the third number, you have to have the 2 prior numbers sum. Okay, so that's why we're doing the sum here. And you see this representation from the function equation for Fibonacci. But in this case, we are using recursion in that in order to calculate the sum, we first have to come up with the first and the second term prior to our current term. Then in the main, we simply declare our n value. We assign that as 11. So we're interested in the 11th term of the Fibonacci sequence. What will it be? So it's going to calculate that for us, and it's going to display. So we have a C out here, and we would then have passed the function here. So we would display the output from our function, and then we would return 0. So in this one, you would see that recursion is applied, and it's very simple. Doesn't have to be complex because Fibonacci is very simple. Then also when we are implementing algorithm in equation format, we want to use algorithm STL and IOStream STL for the C out. Okay. So let me move my bar here. So when we click run, it tells us that at the 11th term, it would be 89. Okay. So if you manually add this, you would find that the 11th term of Fibonacci sequence would be 89. So in our lab, we first take a look at the example in C++, and we would put that into our IDE, and we would run the program. Then we would take a screen capture of the program completion, and then you can paste it into the document, or you can save the file and upload it later as an image. But like before, we would then check to make sure that our result from the program is accurate. Okay. So for 1A, we would then manually calculate the value for Fibonacci. Oops, I am sorry, it scrolled down too quick. So here we would start with f of 0 is going to be 0. So if we seed it at 0, that will be at 0. F of 1 is going to be 1. So these two are going to be your base case, and that's going to be given, right? We always going to start at 0 and 1 or 1 and 1 for Fibonacci. Then when we move over to f of 2, we would take the one before, which is 1, and then the value from the two terms before, which is 0, because that's what's represented here, okay? Then we would add them to get the value for f of 2. So 0 plus 1 is 1. Then for f of 3, we would take the result from f of 1, which is 1, and f of 2, which is 1. Then we add them again. So for f of 3, we would have 1 plus 1, which gives us 2. Then for the fourth term, or f of 4, we would then take f of 2 plus f of 3, which gives us 1 plus 2 is equal to 3. And we would continue to do that. Okay, so f of 5, 2 plus 3 is going to give us 5. 6, 3 plus 5 is going to give us 8. 7, 5 plus 8 is going to give us 13. Then for f of 8, we're going to do 8 plus 13 is going to give us 21. F of 9 is going to be 13 plus 21 is going to give us 34. Then 21 plus 34 is going to give us 55 for f of 10. And lastly, f of 11 would be 34 plus 55, which gives us 89. So our program output is correct. So for 1A, we simply manually go through and build out the sequence, the Fibonacci sequence, by adding the two prior number to get to the next. So the sequence would read 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. And then subsequent to that, you simply take 55 plus 89, which gives you the next term. Okay. So you can show calculation there like how I illustrated it. Any question with the program or 1A? So if I wanted to find, right, the value for the later term, let's say I'm interested in looking at 21, for example, and then I would run and it would tell me that at the 21st term, that would be when n is 21, I would have 10,946. Okay. So Sarah asked, would this be the only way to solve it? No, it's not. Okay. And this is a common way to do it for recursion, right? So this is a very basic. But when you use a recursive function, you would see something like this, where it would calculate the term right before, it would calculate the two term before, add it together to give you the next term. So recursive function is a function that's calling itself. So in order to give you the output for the current term, it has to calculate the two term before, add them, and then give you that. Okay. So we're going to look at different approaches in Fibonacci, but this is a very common approach where you would have the initial condition and you would have the recursive call for Fibonacci. So if I look at 21 for n, I would see this. Now, in recursion, we know that there's limitation. We touched on this before in our other lab. Let's say, what if I wanted to find out that later on, let's say 101, right? And you notice that it is now a little slower, right? It's delayed because as it builds out the sequence, the value, it has to calculate all the ones before that. So as you look at the end value that's further down the line, the larger end value, you would see that recursive function becomes less efficient. And also limitation, okay? So depending on the compiler too, the processor, the RAM, the resources that would be allocated, of course, we have to consider those factors. But this is a common issue with recursive call. Now, what if I stop this and I say, okay, 101, it has a hard time doing. What if I wanted to look at 50, right? Okay. So now if you use Visual Studio, right, and that's installed locally on your computer, you might be able to get result a little bit different than I, because again, we're using different compiler. Okay. So you would see it like that. So in recursive call, especially for the sequence, what you see is that, you know, if we have a lower value for n, we would be able to produce it a little bit quicker, right? And now we're not implementing any sort of data structure to this, okay? So to really build this out a little bit, if you want to consider efficiency, you can think about using recursion, but think about how you store your data as it does that, okay? Because, you know, it has to overwrite the actual storage every time that it updates the data. So eventually down the line, if you're using a very large value of n, it becomes very laggy, becomes very slow, okay? So if you implement data structure, what you can do is you can temporarily store your data and it can go and retrieve the data from the temporary storage in order to be more responsive in the output, you know, as an application. So to come back to Sarah's question, well, yes, we can think of a way to really look at how we can make the program better, not just a very basic program like this, how we store our data, right? All the value in that sequence up until the nth term, which could be a very large value. Okay. So when you address this type of problem, if they give you this type of problem in, like, you know, coding bootcamp for university and things like that, when you come across sequence like this, you think about how you would approach it. And this is the very basic approach. However, right, you would think about how you would position your data so that way it can retrieve it quickly, and think about data structure in your solution. Okay, so let me change this back to the 11, which is what we had. Okay, so for 1B, it asks you to explain how Fibonacci equation is integrated in the program to derive the output, right? We talked about that. Look at your return statement. Okay, do you see this representation there? You have a function and then it's calling itself. Okay, so it has to calculate the one term before and the two term before, add them to give you the result. So we can include a brief statement explaining how Fibonacci equation is integrated in the program. And that if statement is also crucial, right? That condition in our function is important. This one tells us that it seeds at 1, right? It starts at 1, not 0. Okay. So if you start at 0, then you would have n is greater than equal to 0. Okay. So this tells us the start, right? The seed value, the seed position. All right. Then next, after we answer the question there, we would change up our program and we want to replace 11 with 18. Okay. So we wanted to show what the value would be for 18. So if we change this up to 18 and we run, we would have 2584. So 2584 is the value at when n is equal to 18 for Fibonacci. So provide a screen capture of your result for 1C. Any question? Now, if you like using REPL, you can definitely use REPL for your course project. Many of my students previously have done that, right? You can share your program with your team members. You can also use the version control option. It does work well with GitHub. So now you saw earlier that I closed out the file section, the panel for it, but you can definitely make like a directory with all the files that you need. So if you have header file that you wrote, you can definitely add it, have it work together, combine into like a one package. Okay. You can incorporate database and do testing and so on. Now, if you're wholeheartedly like IDE, like VS Code or Visual Studio, you can do that. But anytime that if you write program, you just need a text editor, really, right? Like Sublime or Notepad++. You can even use Notepad. I rarely use IDE. Only on the larger project I would consider using IDE because it helps me organize and debug a little better. But for most part, I just use text editor. And command line. So I'm a little old school. Okay. Because sometimes IDE is some IDE is very complex and you have to still figure out how to use the IDE, right? And then, you know, but that could be simple if you're comfortable with some of the IDE you've been using. NetBeans, you know. I like VS Code in that it's you know, it's compatible with other languages, and if I need to use C compiler. But Visual Studio Community is, you know, it has its thing. So, all right. Next, we're going to talk about number 2 if you don't have any question for 1. So for 2, we are going to look at a similar approach, but in this one, we're optimizing space. Okay? So it's a little bit different than the last one. And we're going to see different approach in our exercises. Okay, so let me go and find my number 2. So this one a little longer, right? And we have a function also called fib. We also use n variable in the parameter. We pass an int n here, and we declare a, b, and c, and I. Okay. Now all of these are integer type. And so in this one, it's going to seed at 0. It's going to start at 0. You're still going to get the same sequence. If you do the math, it's the same. Okay. So it tells us that if n is equal to 0, return a, which is 0. Then we implement a for loop. So if you look at Fibonacci, right, going back to what we had calculated, if you look at the values from number 1, the sum occurs at f of 2. So the first 2 is given, their base. So it doesn't, the function is applied from f of 2 and forward. Okay? Therefore, when we look at the loop on how to implement the loop, we would start with I is equal to 2. That's going to be our start for the loop, because as we loop, we're going to add them. And we're going to go up to the nth term. And we're going to count the loop up each time. So it's going to go 2, 3, 4, and so on. And C is going to be the container, the storage for our sum, right? C is going to be the sum of A and B. Okay. So at f of 2 is when it's gonna add. And to optimize the space, what we can say is A is going to be equal to B and B is going to be equal to C. And we are going to return B. So in this one, we would use a loop to implement the solution. And we optimize the space by using variable. Remember I said earlier something about storage. We have to think about storage. So in the main, we simply, after we return from the function, in the main, we just call the function, right? Fib, and then we pass in. So also in the main, we want to assign the value for variable n, what we're looking for. So here, if I wanted to do 11, I can type in 11, right? I can assign it 11. So it gives me 8, right? And we can try a larger number. Let's say if we do 26. Okay, what if I wanted to do 126? What if I wanted to do 1026? Okay, now what happens? Address. So you do see limitation in different type of programs, right? And when we test it, we have to think about, you know, is it because it's simply giving me an address because it's actually larger than what I had allocated. So I would have to consider using different data type, okay, for the higher value for n.
Professor,
Yes.
could you explain why we need that if statement again?
Oh, because that's for if we look at Fibonacci, if it starts at 0, that's a seed. That's the beginning point, right? In the last one, we start at 1, so it tells you if n is equal to 1 return. So if you start Fibonacci at 1, you would have if n is equal to 1. If you start Fibonacci at 0, because this is a constant. It doesn't, you don't add anything to get this. This is given to you. So the seeding values are given to you. So in Fibonacci, these two are given value. Okay. We don't calculate this. We have to have these in order to get to the next one. Okay. So those are given. So 0, you have to have that condition, because if you don't, right, we don't consider that as part of the sequence. It's still part of the sequence. So if n is equal to 0, it is 0. That's what you're saying, right? Okay. So when you look at that here, it's saying if n is equal to 0, f of 0 is 0. Return 0, right? Now compare this to the last program. If you look at the last program, we seed here at 1, right? So you can start with 1 and 1 or 0 and 1 in Fibonacci. Okay, so you would see some sequence would start at 0 and 1 like this one. Okay, you still get the same output later on, but in Fibonacci, you can also start with 1 and 1, and that's very common as well. You're still going to get 2, 3, 5, 8, and all the subsequent value. So the seed is what we need to state in that if statement. Okay. Any other question? Okay, so put number 2 into your IDE, run it. I want you to test it. Oh yeah, Jason said this is much easier than assembly. Of course, assembly is very unique. But if you understand it at this level anything you can write in C and C++ and Java and Python, you should be able to write in assembly. Assembly just takes a few more steps for one statement. So one statement in C++ equal to about 3-4 statement in assembly. That's it. It's just a little longer, okay? And we have to move things around a little bit more, but other than that, right? So it should be to the point where if you can write it in C, you can write it in assembly. I sometimes, for a program, right, you can write it in C++ first and see how it's like, and then be able to look at it from another language like assembly. But yes, I totally agree. So for those of you who are not in my CIS11 class, CIS11 is assembly programming, and assembly programming is a little bit more difficult. It's not too difficult, but it's different. Okay, I would want to say it's different. So we did a Fibonacci lab in assembly a few weeks ago. And so I had shown them in C++ and then how to do it in assembly. So yes, it's definitely easier. Okay, so for 2, put it in your IDE, run, take a screen capture. Then I want you to verify the calculation. Okay, so if I have a 9 in the screen capture, you have a 9, right? We would say f of 9 is equal to f of 8 plus f of 7, which is 21 plus 13 gives us 34. So Scott, what language are you learning in assembly? Oh, yeah. I used to teach Microsoft ASM. Microsoft ASM, the library for it, it has flaws. So if you're not careful, there are like 5 steps to link that library in order for it to work. It's so much more tedious. And Microsoft ASM has way more instructions. I teach it in LC3, and LC3 is definitely easier to grasp for a student. And I've been successful with it. Many university uses that, but yeah, Microsoft ASM is interesting. You can also build like graphical user interface when you bring in external library. You can make menus, buttons, stuff like that. So, and it uses C compiler. Yeah, I did that the first couple semester when I started teaching for Moreno Valley College. And when I read my survey, the students, they successfully programmed and did the project, but they hated Microsoft ASM. So I had to change it up. But yeah, okay. So I encourage you to really practice it. That would be the best way to get a better understanding of it. And it has like flags and a lot of different things that you have to remember. But sorry, my Zoom. Yeah, if they're using the same book that I use, there are a lot of really great exercises with it, but you should do the little exercises first in order to understand it. Not everybody likes to teach assembly. Okay. Yeah, so if you walk away with that class building a full program with input and output and do calculation, then you are successful. That's more than a lot of the students in a lot of different assembly classes are able to achieve. So try to build viable program with input and output and algorithm. You should be all right. Okay. Okay, so for B, we want to explain how the equation is integrated in the program to derive the output. So this one is a little different, right? in that it uses the variable. Okay, but you do have the sum there where you would take the first and the second term and you would add it. So we would start with 0 plus 1 is going to give you 1, and then we shift it, right? We would then shift it with A is equal to B, and then B is equal to C. Okay, so it updates the value in the variable as we move down the line for the sequence. And we would still have to derive the sum for the subsequent value based on the first two, the two previous values addition. Let me change this to 9 so it doesn't confuse students. All right. So for 2, B, just explain how the equation is integrated in the program. And then we want to calculate the 14th term. So you simply go to where you declared n, and we want to change that to 14 and run it. Then you would have the output. Provide the screen capture after you modify. Then I want you to compare the first and the second program, and to the best knowledge that you have now, explain how efficient the program is, right? Like in program 2, example 2, you use variables, how the functionality of the program or the solution is incorporated. So tell me which one is better in your opinion, right? And we talked about the limitation for these, okay? Let me know if you have question for number 2. So coming back to Sarah's question earlier, now you see 2 options in making or writing a C++ Fibonacci program. Then we're going to look at a third type. Okay. So after you put down the comparison for number 1 and 2 program, right? It's a short paragraph. It's okay, a few sentences. Then you can look at number 3. Okay, so while we wrapping that up, let me go open up my number 3. So 3 is a little longer than 1 and 2. And this one, we're using array. Okay. And we are also implementing loops. So looking at example 3, we again have a function called fib, right? Parameter here we're using int n again. Then we would have an array that is going to store the Fibonacci values in the sequence. Int I here is used for the loop. That will be index. And unlike the last two, where you have that if statement, we simply declare our base values, which is our seeding values. F of 0 is going to be 0. F of 1 is going to be 1. Then our for loop, very similar to the last one, we start at 2 because that's when the sum happens, right, in Fibonacci sequence. Then we would implement a way to calculate the sum for what is been declared. So f of I is going to be f of I minus 1, which is the previous index from the current, and then f of I minus 2, right, 2 positions ago, and we would add them together to get our current value. Then we would return f of n. And in the main function, and then we finish. So my internet is unstable. If I drop off, I'll come right back. Okay, so it still gives me 34 for the 9th position in that sequence. So put it in your, for 3A, we then would verify. And for f of 9, we're going to take f of 8 plus f of 7, which is going to give us 34. So the difference in the third program compared to the first and the second in that it used an array as a container, and we would use a for loop, right, to be able to access the value at each index. And we would loop to add, right? Then we can test it for limitation. So let's say if I put 59, right? So here again, on mine, on REPL, it gives me an address. So when you see a negative number like this, or like a 0x, you know, and a bunch of number, that's also a memory address. Okay, depending on the processor. Then what if I use 39? Okay, I get the output there. So I know I do have limitation with this one as well. Okay. And sometimes you're gonna get the result, sometimes you don't, right? On REPL, it's a little bit inconsistent in that as well. So let me try with 189. Okay, what about 1089? Okay, what about 10,089? And we can go on forever. So definitely you see that it's going to produce larger and larger values. So we can keep adding the 0 and see, right? So ideally, this program is definitely more dynamic than the other two, for sure. So as you can see, when you implement a container like an array, right, you have some flexibility in having just larger storage. That for a sequence like this, that will be helpful. So when you come across this type of problem, again, like I said, in those type of boot camp or challenges that you have to do for at university, right, consider using container for your data. So Jason asked, could we replace fn plus 2 with f of n? Oh, on the top, okay. F of n. Yeah, you're fine. Yeah, you can do that. That you don't need extra element, but in the case where if you expect, you know, yeah, you don't, yeah, you can do int f of n up here, but this is just gonna be a +1 with the extra. So that's fine, you can do that. Because ultimately it is f of n that you are trying to produce, right? Okay. Good question. Then for the rest, we want to explain how the equation is integrated. We want to change up the program and make it 18th term. And then we want to compare number 3 against 1 and 2. Okay. So as you saw, I already tested. Let's look at 18 again. And in this case, what we see here is we see that we're using a loop and we're still going to be able to produce the sum. But as it loops through, it's going to give us the index, right? We're going to start at 2 and it's going to go up to the value of n and it's going to add the 2 prior numbers, the 2 prior index. Okay. And so that's going to give us the value and we want to return f of n. So state the difference or the similarity with the programs. Tell me which one is more efficient, which one is more useful with the container functionality. So you saw 3 approach so far, right? The first one is super simple with recursion, recursive function. The second one, we use variables for space optimization. The third one, we use array, okay, with loops. And we only have one more to do, and we have plenty of time. So take your time. Let me know if you have questions. So as we touch on recurrence this week, right, we talked about recurrence relation is an equation that recursively defines the sequence where the next term is a function of the previous terms. And we see this in programming in our lab. So when an equation is cursively defines a sequence, or you can implement multidimensional array to store the value, but we have to have at least 1 or 2 given term, initial term. Those are the seeds that we talk about to start. Okay. And we experience Fibonacci number today, right? You might be interested in Padovan sequence or Lucas number or Pell number. And you can implement recurrence for those as well. So the Fibonacci in this case, it shows here that you're given initial value as 1 and 1. And for Lucas, they also have to give you initial value. You're given initial value as 1 and 3. Okay. So Lucas is very similar to Fibonacci in that the only difference is that the first 2 values are in Lucas, first 2 values 1 and 3, and Fibonacci is 1 and 1. And then for Padovan, you have 1, 2, and 3 terms is 1. So this little table shows you the difference and how recurrence relation can be implemented in those sequences. So now we can expand on recursive function. Okay. So you saw earlier the first exercise, we did a very simple exercise with recursive function. It would consist of a function calling itself, right? When you look back in that program, you see the function call, right? And then it call itself. So that's recursive. And so with recursive function, it is defined in the terms of the base case and the recursive steps. And the base case of the recursive algorithm is the case that is no longer recursive, right? Such as in the example with factorial function. In the recursive step, we compute the result with the help of 1 or more recursive call to the same function. And we saw that in exercise 1, but with the inputs are reduced in the size or complexity closer to the base. And in number 4, we are going to do a factorial. And this is very common too. for programming to easily see. Okay, it's very, if you look at it, it's going to be very close to what we've seen in the first one. But in this one, it has input and output. So let me pull up number 4. So it's not too complex. It's only C in and C out for most part. We have a function called factorial. Okay. In the main, we have int n. We're going to ask the user to enter the n value. And then it's going to output the factorial result for that. Okay. And for the factorial, you would have, if n is greater than 1, return n times factorial of n minus 1. Because when you're looking at factorial, like a factorial of 4, you take 4 times 3 times 2 times 1. 3 is the n minus 1, right? And then times the n minus 1 of it, times the n minus 1 of it, and so on. So again, we are using a function that calls itself, right? Otherwise, what else we would return 1. Okay. So we can run this. It's going to ask, so let's say that I want a factorial of 10, right? Or I want a factorial of 7. Okay. Or I want a factorial of 34. Okay. So here is where it tells me 0, and you know that's not true, right? Because now it can't calculate it, or it can't output it. It can't retrieve the result, so it's giving me 0. Okay. Let's try a larger number again. Let's do 90. Again, 0. So you're going to see in this one, we're going to have limitation about in the 30s. So let's say 46. Okay. So it's limited for sure. All right. Then after we look at the program, run the program, take the screen capture, verify the result that is correct. So if we do factorial of 10, we have 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. Okay. And if you want to be fast, you can also check with your calculator, scientific mode, 10 factorial. So we want to verify our output with calculation. Then we want to explain how factorial algorithm is integrated in the program to give us the output. So if you look at the program, right, in the function, it tells us that if n is greater than 1, it's going to return n times factorial of n minus 1. So it's going to take n times the previous value, then times the previous value, then times the previous value, and it is recursive here. After we explain how it is integrated, we can change it up to look at 15 and 20. And then I just want you to verify if the output is valid. And you can play with it and test it like I did with higher value, you're going to see. So for 15 and 20, we can provide our screenshot. So we just run it, use 15, run it again. Use 20. Okay. So 20 on mine, I have an address. It's not able to give me the output. Sorry, that was Python from earlier. Okay, then we want to explain the advantages and the disadvantages of recursive function for factorial calculation. You can change the data type if you want, but yeah, so Rashad asked a good question. If for the larger value, then you can change the data type. But what if you have double at the beginning, right? Instead of int? Because if you're expecting, right, a larger result, a larger number as result, we can start with double in the first place. Okay. Yeah, so yes, you can change it. And when you change it, it should be able to hold it. So keep that in mind when you are solving problems, right? Think about the data type and how that would scale with your application. Okay. And the advantages and the disadvantages of recursive function. I touched a little bit on this in the past. We talked about that before, right? We've done some recursion program before. Okay, so for D, I just want you to explain to your best knowledge the advantages and the disadvantages of recursive function for factorial calculation. And you saw that with Fibonacci, right? You saw that with, we did search and sort. I think we did quite a bit. So going back, looking at the example, any question with exercise 4? Okay. So if you complete the lab this evening, you can upload it and submit it. If you don't, you do have a few days before it's due. So not for another couple of days. So you can spend a little bit more time on it if you like. I have some old recording from last semester. I can include that with tonight recording. There's an extra credit quiz game, and you can use either link, right? One link is going to ask you for the input of your game code. The other one is going to let you join directly without having to input the game code. So if you finish the game, you can take your screen capture and then submit it for extra credit. If you have the highest score, I'll send you a gift card. Okay. Don't forget that you have a quiz that's due at the end of the week. So you do have 3 attempts on it, and it's only 10 questions. So if now quiz, I'm fine with you using notes, right? And I open it for 60 minutes for 10 questions. So that's good enough amount of time, right? But for final, it will be closed note, closed books. I do use Lockdown Browser, and I will send out some information. I will post some information about that on Canvas maybe a couple weeks before. Also, I want to let you know that we will have weeks that we will not have lab, okay? I can be available for you to help answer questions about your project, but I will not be able to give you solution for your project. But I can give you some ideas or maybe give you some lead into how you should think about solving your project. Or if you want me to take a look at something, I'm happy to do that. So after a few weeks from now, like when we get closer to toward the end, I will not have lab requirement. I want you to spend the time effectively to do your project. Okay, do not wait till the last minute. And also, sometimes I give 2 attempts. Usually I do, but not always, right? But quiz have 3, and with the final, um, if I do give attempts, it will be another attempt that you would be able to do. But I will do a final review, live final review, where I go through all the questions just to jog your memory. Most of the questions we've done together in class. So you should enter the final if you do the final review. Yep, it's going to be multiple choice. So if you do the final review and if you're able to answer all the questions without looking at notes, you're great, right? You're ready, okay? But if you forgot something, it's a good time to look at, your notes and your exercises that you've done. The project is my way of assessing your application of the concept with programming. The final exam is aimed to assess the mathematical concepts that we've been talking about. It's going to be very similar to the quiz that you've been doing. So it's a compilation of the questions that looks kind of like the quiz questions. It's not all the same, right? So I do have final review material that I will release, and it will be required assignments because I found that it helps the students. And even though, it's additional work, I know that you have a lot of things on your plate, but it's my way of helping you. Where is it? It's my way of helping you getting ready for the final review. So I need to so here, this is the week that I'm looking to have it due is going to be the end of May. So you will get, this module will be activated like maybe a couple of weeks before, so you can start doing them. I just don't want to turn on everything already because it overwhelms the student and then you get confused on what you need to do and you get distracted with assignments. So the next part is to focus on getting through the rest of the chapter. So we still have to cover graphs next week. Okay, we will do an illustration with graphs, and I'm going to try to show you how to use GraphViz, because if you think about going into data science, it's going to help you you know, graphs is heavily used with machine learning, with big data, with, a lot of things. So, and then we're gonna have a week on cryptography, where this, if you're interested in doing Visioneer, we will cover that. So that's going to be unit 11. And then for unit 12, we're going to cover relations and automata. Um, and then we have one last quiz, final review, time for the project. So I should be able to give you some time before the end of the semester to work on your project instead of worrying about the lab. So we do still have a few more labs to go. And so if you haven't looked at the project, just, when you have time, look it over and think about what you wanted to do. So that way, you can plan your schedule accordingly. Okay. And do not wait till the last minute, like I said before. Final exam will be multiple choice. It's 200 points, and I do use Lockdown browser. So before I will turn this on, and it will be password protected. Okay. And I will post the password that week. So that way you would be able to access. Very rarely that I have students that have issue with the password, but in case you have problem, make sure that you contact me right away, and then I'll try to help you. And then there's an last extra credit. It's going to be on course survey. I like to get your feedback. And that is all. Okay. Do you have any question for me regarding lab? Any concern? Anything? Any questions? If not, type your name into the chat. And we are finishing a little early, still light outside, so hopefully you can have dinner with your family, relax, and I will see you on Monday. Have a good night.